Hi, I'm Beth Wilson, one of the hosts of 730, a television show for middle school students produced at the National Air and Space Museum. I know that you all have tuned in today for our live chat, which we'll get to in just a second. But before we begin, I have some words from the Smithsonian to share with you. We know that many of our friends, relatives, colleagues, and fellow humans, both in the United States and around the world, are hurting. Whether the challenge is the COVID-19 pandemic or the unrest and the righteous anger over recent events in Minneapolis, we at the Smithsonian know the only way to solve problems and move forward is by coming together. I encourage you to read the recent message from Smithsonian Secretary Lonnie Bunch on the role that all of us can play in rising to this moment. You can find that statement at www.si.edu/newsdesk. Now I want to start our live chat, and I will begin by introducing our terrific guests that we have today. First, we have Dr. Jennifer Levasseur, who is a curator in the Space History Department. We have NASA astronaut and 10-time spacewalker, Michael López-Alegría. And we have NASA's chief historian, Dr. Bill Barry, who would appear to be coming to us from the International Space Station, which he is not. He's just moving, and that background is a lot nicer, apparently, than the boxes he has in the back today. So let's get started with you, Bill. Bill, tell us about the first American spacewalk and its importance to the American space program.
Sure, Beth, and thanks for the intro there. The key thing I think to remember about the our first spacewalk is that it was an important objective, not just for floating around in space and having a good time, but I'm sure that's a lot of fun. And Ed White was probably looking forward to the chance to go float in space for the fun of it. But the purpose of the space program in the 60s, the goal was to get to the moon and put a human on the moon and bring him back safely. And we had to figure out, how to do that. You could send the crew to the moon in a lunar module, and then they could look out the windows. That wouldn't be quite what we were looking to do. We wanted to put people on the surface that could do real exploration and research out there and accomplish the objective. So in order to do that, you need a spacesuit, right? Because a spacesuit's basically a little spacecraft shaped like a human. And we didn't have a way to do that up until that point. So one of the key objectives of Project Gemini was to test out spacesuits. There are lots of other things we had to do in Gemini to be able to get to the moon, but that was a key objective. That's why it was early on in the program that we started spacewalking.
Now, I want to remind everybody who's watching to put your questions in the comments. We'll get to as many as humanly possible, and also let us know where you're watching from. Jennifer, my next question is for you. Ed White wasn't actually the first person to walk in space. Who was? And tell us a little bit about what the space race was.
So Ed White followed the very first spacewalker by just a few months, and that first spacewalker was Alexei Leonov of the Soviet Union. And for those who know about the 1960s and sort of the context for our American space program, it really needs to be understood as part of a larger story, and that's something we refer to as the space race. Of course, that's a part of the sort of global competition that's going on between the United States and the Soviet Union. And as part of in the 1960s, the space race really becomes sort of an expression, a friendly expression in some ways of that competition. And so that's really a one-upsmanship is happening all over the place in terms of spaceflight and in human spaceflight in particular. And so it's a real challenge to see who can accomplish each of the steps that it could take to get someone on the moon first. And of course, the Soviets had a number of early successes, including the first spacewalk with Leonov in March of 1965, followed by Ed White and Gemini 4 in June of 65. And so just within a few months, both nations are accomplishing similar things. It's always interesting as a historian to look back and see how those things actually happened, how well they went. The two had somewhat different experiences in doing their spacewalking, and they were done in different ways, using different techniques, of course, because they were developed in different countries. But looking back on it and understanding some of the technology that was used is certainly something we at the museum really like to take a look at and think about as we talk to people and talk to students in particular about the activity of spacewalking.
Michael, you have several records for spacewalking. Tell us, what is it like to walk in space?
I'd love to, Beth. First of all, thanks for having me on and joining this very learned panel of historians on an important anniversary for us. It's hard to describe, as Bill said, you're sort of a human satellite, completely free, except for a small wire that holds you to the spacecraft from which you're doing the spacewalk. I can tell you the view is amazing. You're about 250 miles up, going 17,500 miles an hour. It doesn't feel like it, obviously, but when you look down, you can definitely sense that motion. But we really have a very heavy schedule when we're outside, and we try our best not to spend too much time looking around, even though it's very, very tempting. And so it's a pretty intense period. It's a long day. We start very early in the morning getting suited up. And by the time we come back in and get unsuited, it's probably about 10 or 11 hours later. So it's a challenging but extraordinarily fulfilling activity.
We want to remind everybody again to submit your questions. We have some people watching from Kansas, Mexico, Illinois, St. Louis, Oklahoma, Arlington, France. Brian McGuire says hello to me. Hello, Brian. And Bill, Michelle Zajac says hi to you. Let's get to some of these questions that we have. One from Kansas. Bill, I'm going to throw this one at you, and then I think Jennifer and Michael can both follow up on it. How has the suit development changed since Ed White's spacewalk?
That's a really great question, because in the early 1960s, as we were beginning to look at spacesuits, we had pressure suits that could keep people, safe in a vacuum that had been built for high altitude airplane flights. But now you had to build a thing that would not only keep the pressure in, but would protect you from the temperature changes that were in space, because when you're in the sun, it's very hot, as I'm sure Michael can tell us. And when you're in the shade, it gets pretty cold up there. And so they had to be able to do that. But they also had to have a self-contained life support system inside an aircraft or something. You can plug into the aircraft systems to get oxygen and vent other things that you need to get rid of. But once you're out in a spacesuit, you need to have all that stuff either there with you or piped to you through a pipe, which is what we did with Ed White. He had an umbilical that provided him with oxygen and things like that he needed. But even then, you had to build a spacesuit that could regulate those things, and we just didn't have that. So we had to develop that. And then, of course, as things went along, we went from floating in space as we did in the early Gemini missions to trying to do actual work in space, and they had to develop the spacesuit in new ways. And then to walk on the moon, we had to develop a new spacesuit. And then in the course of the last 50 years, we've also had to develop spacesuits for other purposes, and they're modified over time. And there's been a lot of change in the spacesuit technology over the years.
Yeah, go ahead. If you had a question, Beth, but I was going to say one of the things. What's one of the great things about the museum's collection is you can see that in evidence in the museum's collection, and our spacesuit curator, Kathy Lewis, has a wonderful selection of those to really show that exact path from the beginning, when we were really still developing and basing the design developments on flight suits for pilots, and how that has gone through all these changes. Now, one thing that's true about the museum's collection that's often a surprise to people is we do not have a representation of the spacesuit that's been used for the last almost 40 years. And a limited number of those were made, and they've been improved, in little increments, especially the gloves over time. But that spacesuit is still those spacesuits are still being used today by our astronauts on the International Space Station. And so those parts have been reused by an awfully high number of people, which I find both a little creepy and really interesting in the way that we've economized in a way about reusing spacesuits. They're no longer designed for a single person. They're designed for multiple people to use in different sizes. So I would imagine Michael might have some feedback and thoughts on that.
And before, Michael, to sort of go back to what Jennifer alluded to, the suits are different, but there's something important about the gloves. So if you want to talk about the suit today and talk a little bit about those gloves.
Yes, I would say that since the beginning of my career anyway, in 1992, the spacesuit has been the same. It's called the EMU Extravehicular Mobility Unit. And there have been a lot of tweaks to it. I would say the most important is probably an improvement in the gloves. And the gloves today are actually fantastic. We have, they're basically custom made to everybody's different hand sizes. By the time somebody new comes along now, they can usually find somebody's hands that are enough like theirs to use that style glove. But they're heated, they're quite dexterous considering you're under, 4.3 pounds per square inch of pressure, so about a third of an atmosphere, which makes things pretty stiff. The soft goods, the legs and the arms, which are fabric, feel like they're made out of iron when you're wearing them. That's how much the pressurization affects them. We've had some other improvements to include, as Jennifer mentioned, we used to fly the suits up and down on the shuttle, but now they stay on the space station for extended periods of time. And so we had to figure out a different way to recycle the cartridges that take the CO2, the carbon dioxide, out of the inside of the suit, which is obviously very important, and actually generally the limiting factor in how long an EVA could go. And I could go on, but there are a lot of improvements to make the suit be sustainable in orbit, as well as to improve the tools that we use to do the work on the ISS.
We have people watching from Texas, Wisconsin, Plattsburgh, New York, Germany, Oklahoma, and India. If you all are watching and enjoy this, please feel free to share it. Just click the share button. And again, put your questions in the comment section and we'll get to as many of those as we can. This is the first time we've had to translate. We have a question in from a viewer in France. We had to run it through Google Translate. So we'll see how good this is. This person would like to know, according to Google Translate, do you think that life is possible in space? Jennifer, why don't you?
Yeah, I would say, I mean, we've definitely been proving that for the last 20 years, that it is possible to have a persistent presence, human presence in space, and that's happened aboard the International Space Station. The first inhabitants started up there in late 2000. November of 2000 was the first expedition, and there's been that constant presence now up through Expedition 63, which is going on right now. And so we've had people in space over the last almost 20 years, and I think that's that's an indicator that we've found ways. Now, that doesn't mean a single person could stay in space for all that time or even for very long times. Radiation is a limiting factor for sure, and how long one can stay in space. And I believe there's a limitation on your lifetime exposure in that sense as well, that you can't be exposed past a certain point. But those measurements are taken, and we want to protect the astronauts and individuals from going up into space and being affected by that. So yeah, there are challenges. And so we have to think about that as we go on to longer missions, especially to places like Mars, where a mission could take up to 3 years. And how do we then protect people in that sense? Is long-term in orbit possible? Maybe. We've got some good protection out there thanks to the Van Allen radiation belts, but living off-world where there is additional protection from an atmosphere is probably finding a place where we can find resources that are similar to Earth's would certainly be sort of the best solution to some kind of off-Earth life.
This is sort of a two-part question. I want to start with you, Bill, because I know that there's a story behind this, that Ed did not want to come in from his first spacewalk, that he was having such a fun time. And I know there's a longer story. And then to follow up with Michael, is that your experience as well?
Yeah, it's true. They were talking to Gus Grissom, who was the Capcom at the time on that mission, and Ed, who was out on the spacewalk, and his crewmate Jim McDivitt, who was inside the Gemini 4 capsule, still flying the spacecraft. Were chattering so much back and forth that it was hard for mission control to get a word in edgewise, and Gus was trying to get their attention to let them know that it was time for Ed to get back in, and he finally got pretty frustrated when he finally got a chance to get their attention. It's like, get back in was his direction. And I think Ed was pretty sad. He described it as the saddest moment of his life when he had to get back in.
So what has your experience been, Michael, with, are you
I have to
always
say,
excited?
if I remember right, the first spacewalk by Alexei Leonov, may he rest in peace, was something like 12 minutes long, and the ones that we do now are usually, they're targeted for 6.5 hours. They generally go around 7. And I'd say by that time, it's like running a race. You know, it's a lot of adrenaline, a lot of intensity. You're physically tired at the end of it. I think, especially if you've been able to keep on the timeline and get your tasks done, you sort of want to come in and live the moment for a second. But coming inside the airlock and closing the hatch it's a tough emotional feeling, because you're really it's an extraordinarily unique opportunity, and you know, at least for that day, it's over.
What is the lifespan of a spacesuit, and how many times can it be used? And then I will follow that up with Jennifer mentioned that we don't have spacesuits from the International Space Station. So once you're done, what happens with them?
Well, spacesuits back in, you know, sort of historically before the space shuttle era were really single-use items. They were designed very specifically, the entire suit, to the custom measurements of each individual. And then they would basically be retired, and sometimes not retired for the purposes of a museum collection, but retired to training purposes. And so we do have evidence of those suits, some that even flew to the moon, being reused later in training missions back at NASA. So there could be a life beyond just a single mission, but the suits that were designed in the early 80s for the shuttle era that are still in use today, those parts are used until basically they're worn out. And sometimes they go on to a life of being used in the neutral buoyancy lab in Houston for training purposes. But they really have had a long life. I believe it was Kathy Sullivan's hard upper torso, and that's the portion that sort of is up here where your arms kind of poke out your head and your lower body. I believe that the piece that she used as the first female American spacewalker was then reused on a recent spacewalk by either Jessica Meir or Christina Cook. So that gives you some sense of the potential longevity of a single piece of equipment.
Harper in Arlington would like to know, what is the hardest thing you have to do to prepare for a spacewalk?
Well, certainly the training is long and extensive. For every time that we do a scheduled spacewalk, you probably spend about 40 to 60 hours underwater practicing for that spacewalk in the neutral buoyancy lab that Jennifer mentioned. And that is physically tiring. It's a little tough on your body. You get hot spots in your suit. You spend some time upside down in the suit, which in space is fine because there is no up and there is no down, but in the water, there's definitely an up and a down. So when your head's down, you're supporting your weight on your shoulders, and that can be painful. So I'd say that's it. That said, nothing can prepare you for, you know, the first time you stick your head out the hatch and see those sights that I mentioned before. The NBL is a fantastic training platform, and you really do feel a sense of comfort because most of what you see is familiar, but what you don't see are safety divers or bubbles.
Hey, Beth, I have a question for Michael, actually. You brought up the word tools earlier, and you mentioned the developments with the gloves. But one of my favorite stories, and it's because it was such an interesting lesson, is the story of the spacewalk on Gemini 9 when Gene Cernan really got overexerted and his heart was racing. And there were some key tools that were developed because of that mission in particular to help astronauts make a spacewalk easier. So can you talk about some of the tools other than the spacesuit that you used that really helped the process?
Well, I think the gloves would be at the top of that list because that really helps you move around and stuff. I don't know if you're alluding to the fact that we have a rescue device now that would, in the event that we would become detached, as I mentioned, we're always attached to the structure with a tether. And it's extremely unlikely that that tether would be broken, but it's less unlikely that you could make a mistake when you're changing tethers or attaching it. And in the old days, in the shuttle, if that were to happen, they would just chase you down with the space shuttle. But when we started building the ISS, it became pretty clear that at some point, the ISS was going to be too big to maneuver to do that. So we have a simplified aid for EVA rescue, or SAFER, which is an attachment to the backpack. It's fairly primitive. It's nothing like what you might know as a manned maneuvering unit, which was flown, in the early to mid 80s to do satellite retrievals and things like that, which was really sort of a Buck Rogers thing, extraordinarily sophisticated with lots of redundancy. The S in SAFER is simplified, and it is just that. So you don't have too many chances, but it's, I got to test fly it on one of my missions, and we practiced in virtual reality. And the goal of the test was to determine how well that virtual reality matched the real reality, and it was pretty darn good.
Bill, if I'm going to follow up on that question a little bit, one of our viewers would like to know, do you think the simplicity of the spacewalk in 1965 caused a false sense of security for future spacewalks when it comes to those handhelds?
Yeah, I think that was really a surprise, because Ed White's spacewalk went very well, but he really didn't have to do anything other than to float around. He tested out the little handheld maneuvering unit, and that seemed to work pretty well. So it gave the planners a fair amount of confidence, and folks in planning missions in Project Gemini, they had so many things to accomplish that they thought, well, okay, so we'll worry about the EVA spacewalk thing as we get further along, but it looks like it's not going to be a big problem. And so they had some very aggressive plans for, particularly Gene Cernan got mentioned on a Gemini 9 mission, which we're in the middle of the 54th anniversary of that this year. It just launched yesterday, and 54 years ago. And Gene got out there and had a very hard time, because he was supposed to maneuver around the spacecraft and do a whole bunch of very sophisticated tasks. And even just getting from one place to the other around the Gemini spacecraft proved to be extremely difficult, because the spacecraft wasn't built for anybody to be grabbing a hold of it. It was built to come back into the atmosphere after flying around in space. So it took a little bit of readjusting of their approach to things, and the development of underwater training, which was an idea that was kind of bubbling along there, so to speak, in the early 60s, but that NASA didn't really get serious about it until after it had problems with the later spacewalks and the later Gemini missions. So, but by the time we get to Gemini 12, and Buzz Aldrin has a very large schedule of things to do, multiple spacewalks on Gemini 12, and he knocks all those things out very effectively, because he had handholds to hang on to. He had a very well planned out, choreographed plan for the spacewalks, and also he did a lot of underwater training. So that we learned a lot in those early Gemini missions about what not to do as well as what to do, and handholds on the outside of spacecraft, turns out it's a really important thing.
Does height play a factor in who can fit into a spacesuit and who goes on the walk and who doesn't?
Well, we have 3 different sizes of what Jennifer referred to earlier as the hard upper torso. So it's kind of the jacket of the spacesuit, and that's really the determining element for sizing. All of the other pieces, the upper and lower arms, upper and lower legs, all of those come in multiple sizes that you can sort of mix and match to get to the right size. But I would say it isn't so much height as wingspan. It turns out, being able to reach from one fingertip to the other pretty far is a very good indicator of how well you'll be able to work outside. Now, of course, that's a big generality. There are a lot of smaller people who do just fine, and just because you're tall or have a big wingspan doesn't mean you'll work great. But it's a good indicator, and we have more of the bigger size hard upper torsos than smaller ones, I think, for that reason.
This is a question that we get a lot of this coming in. So I'm going to ask all 3 of you. I'll start with Bill. What are some of your favorite books on the early space program? So Bill, what are some of your favorite books?
Oh my goodness, I have to choose. I have a whole large library of books about the early space program. Um, let's see. Well, of course, there's an entire official NASA history series that the History Office publishes, and those are all good, solid histories. In fact, preparing for this event today, I took a look back at Standing on the Shoulders of Titans, which is our basic history of Gemini, which is a good book. I think probably my favorite space book from the 60s is probably Michael Collins' autobiography that he wrote. Beautifully written, as well as very insightful into the life of an astronaut.
Jennifer, what about you?
It's tough to say. I mean, the astronaut biographies are always a fun read, if not really informative, and just kind of just engaging in the sense of feeling like you're kind of living through somebody else and reading that. I will agree with Bill, though, that Michael Collins's autobiography, Carrying the Fire, is, I don't know why. I've often said this about books, is that when I feel I'm reading and hearing that person's voice as I read, that it is a well-written book. And I think for that reason, it's an incredibly well-written book, because it really captures his voice. Yep. And the person who is, is experiencing all these incredible things going on, and part of a moment that, is obviously one of the most important in American history, with the landing of Apollo 11. So, but I would be remiss if I didn't mention Jim Hanson's First Man, because it is just a real, it changed, I think, a lot of the ways that we think about biographies and writing biographies as historians. Of somebody, he spent an incredible, 3,000 hours interviewing Neil Armstrong. And I don't think that that's an opportunity that most of us ever, dream of as historians. And so he really used it. And obviously it's had an incredible life of its own after the book came out as well.
And Michael?
Well, I feel that it would be a little presumptuous of me to think I could add books to a list that was created by a couple of historians. So I'll answer a different question, which I often get, which is about movies. And, recently the Apollo 11 movie that came out, in the year of the celebration of the 50th, I thought was fantastic. It's a documentary with basically no dialogue, just natural sound from interviews and anchors and things like that. And I recently saw a similar one called Neil Armstrong, about him, obviously, which I thought was quite good. And in the not so documentary category, Apollo 13 is a classic.
Yeah, that's a very good one. I'm going to throw in The Right Stuff was one of my favorites when I started at the museum. It kind of gave me a really good overview. And if you're looking for a new book, Jennifer has one out called Through Astronaut Eyes. So be sure to check that book out. We really want everyone to read Jennifer's book. Kristen from Colorado would like to know, are any of the space agencies trying to make technology that will help halt the bad effects of long-term space flight? I think that's a really interesting question, and I don't know who to pitch it to. So I'm going to start with Jennifer, since she's my colleague at the museum. So
yeah, I think that's a big message of what's happening generally in terms of research in space right now on the International Space Station. And so the work of NASA astronauts and astronauts from all of the partner nations that are spending time on the station are doing experiments that are meant to both inform and help life on Earth, and then really inform our path going forward towards whether that be the moon or Mars, or just continued life in orbit. Is that there are some critical technological developments that are to be found in terms of making things more efficient, or finding ways to conserve critical resources. There's no water just floating around in the atmosphere like we have in lakes and rivers and streams. We can't tap into any resources. So we have to get those resources wherever we're going. And so it's important to find ways to do things like recycle water, which I think is a really key development that's happened in the life of the ISS, is basically taking water vapor and other liquids and recycling them to make them drinkable, potable water. And so, there are developments like that being researched on the station all the time. One of my new favorite experiments is called AstroRad, which is a vest that's being developed in order to protect astronauts from radiation. And so I encourage people to look it up. It's a really fascinating experiment. It's up on I believe it's still up on the station now, and we'll fly on the first Artemis mission to the moon and really test in what ways can materials be used to protect astronauts from the exposure to solar radiation. So there's lots of really interesting things going on, and a lot of that then can reflect back to life on Earth in ways that we can do things like better solar cells, more efficient solar cells for producing electricity and things like that.
Bill, what do you think some of the earliest experiments that helped move us from Skylab to the International Space Station help prepare us for that longer period of time in space?
Well, of course, there's this gap. We flew Skylab and our first attempt at a space station in the mid 70s, early 70s. And then we've got this long gap until we build the International Space Station. But during that time, we're flying on the space shuttle. And as Michael will tell you, there are lots of missions that got flown there where we did lots of different things. But along the way, the idea had been that we eventually want to build a long-term space station. And so the experiments on the shuttle were some of them aimed at testing out technologies that would be useful for that, construction techniques. There were several shuttle missions that featured long EVAs in the payload bay where they tested out assembling large structures and you put them together and sort of crank them out like some sort of erector set thing, or do you put pieces together and they sort of spring open on their own? There are lots of things that get tried out. So we're actively aiming at the long-term objectives, even back in those days when we weren't really flying on a space station.
Michael, you worked in building the space station. What advances did you see as you went along in that process?
Well, I pick up on something that Bill said. He described a lot of the kind of technical developments that we were working on since Skylab all the way to especially in the shuttle program, early shuttle program to build a space station. But the human aspect of that was really not addressed. And I think when you think about a short duration shuttle mission, which is on the order of 2 weeks compared to about a 6-month stay on the space station, there are very different behavioral health issues that arise. And one is more like a sprint. The other one is a marathon. When you're running as fast as you can, it's easy to not be distracted by other things, so things like interpersonal relationships and living in close quarters and separation from your family, those things are really not in the forefront as they are when you're away for 6 months at a time. And we started learning about those in the Shuttle Mir program, which was sort of the phase 1 of the ISS, where American astronauts were spending about 3 or 4 months at a time on the Mir space station. And boy, we had our eyes open. And since then, NASA was very proactive to try to learn some of those lessons and institute a relatively formal training plan to help astronauts cope a little bit better with those problems.
Lily Sawyer likes my Catronaut. That's behind me. Thank you very much. Some other books that viewers have mentioned, some newer biographies by Scott Kelly, Leland Melvin, and Mike Massimino. Those are some that some great reading for those of you who are interested in astronaut biographies. An 11-year-old from Wisconsin would like to know, what are spacesuits made of? Now, this is an answer that changes with time. So, Bill, do you want to talk a little bit about some of the interesting hard suits and then how it moved into soft suits? And Jennifer can talk a little bit about some of those in our collection.
Sure. As we mentioned earlier, originally, spacesuits were a spin-off of the pressure suits that were used in high altitude flying. But people took a pretty different view of other ways you could address the problem of operating in space. And there were designs that were based to some extent on deep diving suits that were heavier metal and bigger helmets, where basically you had a person inside a robotic sort of suit where they had things that they manipulated inside, and it wasn't so form-fitting. And so there was a variety of suits that were developed in that sort of genre, and then there were other suits that were more the form-fitting kind. There are projects going on right now where David Newman, a professor at MIT and a former NASA official, is looking at this form-fitting suit idea. That's that if you've seen the movie The Martian, those suit bases in The Martian were modeled on that sort of suit, that not so bulky. So there's lots of different ways you can approach the problem. And in the early days, some of the ideas were pretty wacky. If you get a chance to ever go inside the spacesuit repository at the museum, which I had the good fortune to do one time, there's some really interesting variations on a theme in there.
Yeah, well, one of the important features of the spacesuit that we've certainly had to deal with is that it has to contain pressure, and to do that you need a layer of the pressure layer itself. And so with a lot of early suits, it's rubber, and that rubber, and if you think about even something like a newspaper that gets left out in the driveway for a few days while you're on vacation, it starts to yellow, and that newspaper, if you brought it inside, it might become brittle. And materials like even your plasticware that you have, that may be maybe a decade old, there's a smell that begins to have after a while, or can have. And so there's a character to the materials themselves that can interact in a negative way with each other. And so what we found in the museum's collection is those rubber layers are aging, and they're becoming brittle, and they're drying out basically, and they're fracturing and kind of dissolving almost. And some of those other materials are drying up as well. And so they're yellowing with age, and we need to find circumstances to put them in, storage circumstances and also display circumstances that will keep them in ideal conditions. And so not only temperature, but humidity as well. And of course, in the case of Neil Armstrong's spacesuit, we just recently put it, like a year ago for the 50th anniversary of Apollo 11, put it back on display in a very specialized case in order to protect those layers. And the layers of a suit now are far more complicated and numerous than they have ever been before. So I would think Michael might have something to say, especially about that outer layer, which people can really readily identify with.
Yeah, you're right. And we mentioned the hard upper torso, but the soft goods are multiple layers that have a lot of different functions. There's an inner layer that's up against your body. Then there's a restraint layer that actually holds the pressure. And outside, there are multiple layers of insulation. So as Bill mentioned earlier, the temperatures in between day and night, which by the way happen every 45 minutes, can vary from about 100 below zero to 200 degrees above zero, just like that. And what's amazing is you hardly feel that change in the suit. That's how good the insulation is. You feel a lot more changes in your own body temperature by how hard you're working or not. But as far as the sun impacting on it, which you would think would be dramatic, it's actually very good. So the multiple layers of insulation is key. And that's obviously why the suit is white, is to try to reject as much of that heat as possible.
We are running out of time, but I'm going to wrap up with sort of a two-part question. Chet from Marriottsville, Maryland, would like to know if one upgrade could be made on the spacesuit, what would you recommend? And can you talk a little bit about the new SpaceX suit and what the differences are between what we're currently using and that suit development? So Michael, what is the one upgrade that you would want?
If there's just one.
I mean, you'd always like to have better mobility. And I think I was fortunate enough to do 2 spacewalks in the Russian Orlan suit, which is also a great suit. Similar in many ways and very different in others. But I can tell you that from a mobility standpoint, our suit is far superior. So you always want to keep working on that. I think what Professor Newman's doing up at MIT might be a step in that direction. But you also, the lower the pressure in the suit, the more maneuverable it is logically, but there are dangers associated with that that have to do with decompression sickness. So there's a big trade-off there. So I think if we could do anything, making it more mobile and less bulky would be what I would go for. And then regarding the SpaceX suit, I mean, I think it's important to point out that is not an EVA suit. That is a suit that protects the crew where there be a case of depressurization in the capsule, but it's not meant to be outside for any period of time or any thermal environment, radiation environment, et cetera. It is a pressure suit, but for a much more different application.
So it's similar to a Sokol suit that you wore up on a Soyuz or the launch and entry suits on a shuttle, right?
That belongs to a class of suits called launch entry and abort suits, which are just for those three things.
Well, thank you all for joining us today. This has been really great. I have learned personally a whole lot. I want to remind everybody that we are doing these live chats every Thursday at 1 o'clock. Our next one will be the Dragonfly mission to Titan, and Elizabeth Turtle, who is the PI on the Dragonfly mission, will be joining us. And then the following week, we will have a pilot panel, including Shasta Ways and a U-2 pilot. Thank you all again for joining us today. This was really informative. I really appreciate it. And we'll see y'all later.